The Beer-Lambert law is the linear relationship between absorbance and concentration of an absorbing species. The general law is usually written as A equals A times B times C. In the equation, A is the measured absorbance. An absorbance of 1 happens when 90% of the light at that wavelength has been absorbed, which means that the intensity is 10% of what it would otherwise be. For each of the dilutions, transfer sufficient, but not excess, solution to the cuvette. Fill the cuvette up to the line using a transfer pipette. Use deionized water for the blank. Clearly wipe 2 sides of the cuvette, of all cuvettes, before placing it into the spectrophotometer. Remember to zero the blank and replace the blank with one of the dilutions. Remember to wipe the sides of the cuvette with the arrow and its opposite side. If there is no arrow, wipe all 4 sides of the cuvette. Place the cuvette in the spectrophotometer with the clean sides in the beam. Close the spectrophotometer before scanning, and scan the absorbance of the sample. Don't forget to record the absorbance of the sample in your notebook, and then carefully remove the sample from the cuvette and close the door. We zero the spectrometer so that the absorbance readings will have a basis to be compared to. You scan across all wavelengths in the spectrophotometer because you have to find a specific wavelength at which dilutions are best absorbed. You can also scan at a specific wavelength so you can see which concentration has the highest absorption. We can tell the concentration of the unknown using both techniques. After finding the optimal wavelength, you would see the lambda max, which is the peak. This signifies which concentration has the highest absorbance